Hey everyone, so this is a video about triangle inequalities. Inequalities being the little Pac-Man symbol that eats the bigger number. That's a triangle inequality. And we're going to talk about ranking sides and finding ranges of sides. And we're not going to find a definite length, but we can tell which one's bigger and which one's smaller. And that's why it's called an inequality. So by the end of this video or this class, you will be able to rate the sides of the triangle from least to greatest. You'll also be able to do that with the angles from least to greatest. You'll be able to determine the side lengths if sides can make triangles, and also the range of values for a missing third side of a triangle. Now, there are two activities that you are going to do with these objectives, and you're going to watch. You should be watching the video after that. So, triangle inequalities. Okay, they rank the sides and the angle by size. We don't know the definite size of the side, so we don't know if like one's 5, one's 6 centimeters. Okay, but we can tell which one's bigger and which one's smaller. So by knowing the sides, we can rank the angles, and if we know the angles, we can rank the sides. Okay, so this is called angle and side relationships. Okay, so what it says is that the largest side is across from the largest angle. Okay? Likewise, the smallest side is across from the smallest angle. Okay, so that's a property that we need to be able to rank the sides. So if we're looking at example 1 here, so we notice that all the sides are measured. So if we're going to list the angles in order from smallest to largest, we need to rank the sides from smallest to largest. So the smallest side is this side, SR. And that's a segment, remember. Okay, the next side is ST, okay, and then RT. So that's from least to greatest. Now the angles are the ones across from it. So SR, the angle across from it is T. So angle T is the smallest angle. All right. Across from ST is angle R. And across from RT is angle S. You'll notice also with the sides and the angles, okay, there's RST in the triangle. The side is SR, the angle is T. So they don't mix up the 3 points or the vertices that we have. In this equation, or in this example, we're given all the angles, okay? So, again, we're going to list the sides in order from shortest to longest, okay? So, what we do is we measure the angles from smallest to largest. So, the smallest angle is angle A, right here. Then, angle C. Then, angle B. Okay, so the smallest side is across from A. Okay, so across from A, it opens up to it, is this side CB. Remember, that's a segment. Okay, and then across from C is this side AB. And then across from B, again, the connecting those hands, okay, is side AC. And you notice that none of the the vertices repeat. Okay, so that's how we measure or rank the sides in angles from smallest to largest. So for the next few examples, okay, you need to do both things. Okay, so you need to list the angles and the sides from smallest to largest. Okay, so there's two angles, so it's just repeating that process again. I'll do another one for 2. Okay, again, you have to list the angles from smallest to largest. So smallest is angle T, then angle R, then angle S. So that's smallest to largest. Then the sides are side SR across from T. Okay. ST, the angle across from R, and then the final angle, or side TR. Okay? So again, smallest to largest. So that's a triangle inequality. Okay? The other thing that we had to do was talk about the inequalities of the sides. Now this was the second activity with the spaghetti and ranking it. So what we learned in a triangle, the sides A, B, and C, okay, the two smallest angles sides had to be bigger than the third side to form a triangle. Otherwise, when I put the two things together, they're not going to form a triangle. It's going to like fall flat there. Okay? So what happens is, okay, A plus B has to be greater than C. But also, A plus C has to be bigger than B, and B plus C has to be bigger than A. So what you really want to take away with this is you don't have to do all of this. Okay? Let's say C is the largest side, okay? What you have to take away from this is the two smaller sides have to add up to more than the largest. And if I go back to some of those examples back here, okay, where we had the side lengths, you'll notice that 14 is the biggest, okay? 5 plus 11 is bigger than 14. So 16 is bigger than 14. Those side lengths are going to form a triangle, okay? So that's our next couple examples. Okay, and it's written out right here. You can write it down on your definition sheet if you want. But here are some examples of this. Okay, so is it possible to form a triangle with the given side lengths? Okay, so this is when you're doing it. So if I give you the side lengths, 3, 4, and 6. Well, 6 is the biggest side. So all I do is go 3 plus 4, is that bigger than 6? So 7 bigger than 6? Yes, it is. So yes, it can form a triangle. Okay? But if we look at number 2, again, 15 is the biggest. But if I do 6 plus 9, is that bigger than 15? Well, 6 plus 9 is 15. This says, is it bigger than 15? It's exactly equal, so it's not bigger. So it's not able to form a triangle. Okay, those actual sides will actually fold in on themselves. They'll be like on top of each other, forming almost just like a segment when that happens. So that is being able to tell if a triangle will be formed by given side lengths. Now, the other tricky part, okay, is finding the third side. So if I give you a triangle, 5 and 8, but I don't know this one, okay, I need to be able to find a range of values, okay, that will be that third side. So we know that if I add these two together, it has to be bigger than this, right? So 5 plus 8 has to be bigger than x. So my max value, okay, for x has to be 13, actually less than 13, okay? But let's say 8 is my biggest, okay? So really, that missing side plus the 5 that I'm given has to be bigger than the 8. Well, solving an equation, that third side has to be bigger than 3. So the range of values is actually has to be bigger than 3, but less than 13. Anywhere in between there would form a triangle. So let's say I choose this to be 10. Okay, well, 5 plus 8 is greater than 10. Okay, well, let's say it is 5 again. 5 plus 5 is greater than 8. Boom, okay? But if I choose a number like 2, well, 2 plus 5 is not greater than 8, so it won't form a triangle. So these are the values that will get me a triangle, okay? Now, I'm going to do the same thing here, okay? Again, I would do a 1 plus 6 has to be greater than x. So x has to be less than 7. Or x plus 1 has to be greater than 6. So x has to be greater than 5. So x has to be between 5 and 7. Okay, so any number between 5 and 7, 5.1, 5.2, 5.3, that sort of thing, will form a triangle. Okay, so that's how you do these types of problems. When you're finding the range of the two sides. The third avenue is actually comparing two triangles. Okay, so again, it's just going back to which one's bigger. Okay, so you notice that these two sides match up in the two triangles. Okay, RS is congruent to AB and ST is congruent to BC. The only thing that is different is between this 80 degrees and this 60 degrees. So if you imagine 60 degrees and then I move it up to 80, which has a bigger distance between these two pens? Well, obviously the 80 degrees is bigger than the 60 degrees if I measure it with a ruler. That's why it's called the hinge theorem. All it takes is a hinge, okay, and all I'm moving is the sides. And I'm measuring the distance between the open ends there, okay? So to rate these, okay, I would say that RT is greater than, remember the greater than symbol eats the bigger thing, is greater than AC, those segments, okay? Now, the reverse, okay, let's say I have 36 and 33, same type of picture. Now, I gave you the segments, now I can rate the angles across from each other. 36 is bigger than 33, so angle M is greater than angle R. And then I'm done with that. All I'm doing is ranking the sides. So the hardest thing here, okay, again, I'm just measuring these things, okay, is when they overlap like this. But again, all you're doing is looking at the angles, okay? So how does GF compare to FE? Which one's bigger? Which one has the bigger angle? Well, this one's 28, this one's 22, so GF is bigger, this segment right here is bigger than that FE. And again, over here, okay, I'm comparing angle A ABD, this angle, and angle CBD, this angle. Well, which one's bigger? 16, 13? Well, the 16 wins out. Okay, so the ABD is bigger. So that's all you're doing is ranking the two sides. There's an application where we can actually set up equations too. So that's something like this. Okay, what you'll notice is these are all the same. Okay, the only difference is this 120 and this 115. Okay, so I know this 4x minus 10 has to be bigger than this 40 based on the two angles, 120 and 115. Now what I can do is actually solve this. So for this side to be bigger than this side, x has to be bigger than 12 and a half. So I could plug in 13 here and that would work. I can't plug in 12 because it would be less than that to make this true. So please complete the rest of these practice problems and check your answers and check in with me. You should be able to rank the sides and angles from least to greatest and determine whether the sides of a triangle form actually a triangle. And remember, always check your answers and ask questions.